In class, we did converting fractions into decimals and decimals into fractions. The first thing to know about fractions and decimals is that they convey the same information. So when you have a fraction 1 over 2, that becomes a decimal, 0.5. That means the same thing. They're written in two different styles so we can use them in different ways. 1/2 might be an easier algebraic use, while 0.5 might be a better practical use. Now the word decimal is short for 10. So when we're working with our 10 number system, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, those are our 10 numbers. We break these fractions, if we can get it to be 10 on the bottom, that's how we're getting this decimal over here, and any fraction's decimal for that matter, is we're converting it out of our 10 place value. And that's all because numbers are built on the decimal system. So this is the ones place, this is the tens place, hundreds place, this is the tenths place, like we're a snake, tenths, hundredths place. Each one of these jumps is 10 times or bigger or 10 times smaller than it used to be, all because of the decimal system. So knowing our place value like this, we're able to go from decimals into fractions pretty simply. So we're going to start off with terminating decimals. So these are decimals that end. So that's our overarching idea as decimals into fractions. We're starting with our terminating decimals. For instance, 0.25. That decimal has come to an end. It has a definite place value right here. So when you have a decimal like this, we're going to look at the last place value that it's in. That's in the hundredths place. And so 0.25 becomes 25 out of 100. We should then always simplify any fractions that we have. 5 goes into both of them, but so does 25. 25 goes into 25 one time. 25 goes into 100 4 times. So 0.25 is the fraction 1/4. If we have a decimal like 3.37, the 3, that's a whole number. So when we write our fraction, we still have that 3 whole number for our mixed number. We look at the place value for our decimal. That's once again the hundredths. And we get 37 over 100. We look to simplify. Nothing goes into 37. So nothing the same goes into 37 and 100. And so our fraction is done right here. If we had a fraction that had more decimals, and let's make it negative for fun, negative 2.129. The negative 2s, that's the whole number. It goes out in front. The 9 is in the thousands place. And then we have 129 on top. We make sure that we can't simplify it at all. 2 doesn't go into both. 3, 4, 5, 6, 7, 8, 9, 10. None of those. 8, 9, 10, 12, 13, 14. This is as simple as it can be made. So terminating decimals, all we have to do is look at place value. But it's when they're not terminating decimals that gets a little bit dicey. So the other type of decimals that we are able to convert into fractions are our repeating decimals. So repeating decimals come in two forms, where all decimal digits repeat, or just some repeat. And we have to approach them slightly differently. So for now, we're just going to worry about all of the decimals repeating. For instance, this would be 0.3 repeating. Notice that every single decimal digit has been repeated. This would also be true if we had something like 0.45 repeating, or even if we had 0.124 repeating. I'm going to change this last one because I don't really want to deal with that one for right now. I'm going to make it something different. Let's go 3, 2, 7 repeating. Notice that in each one of these examples on this left-hand side, every single digit is being repeated. That bar is over all of our decimals. When that happens, to convert it to a fraction, we put the decimal digits that are being repeated, so in this case the 3, in this one the 4 and the 5, this one the 3, the 2, and the 7, and we're going to put them over the same amount of 9s. So same amount of 9s. So 3 is over 9. 45 is over 99. 327 is over 999. We're now going to check to see if we can simplify any of these. This top one, both are divisible by 3, so we really get the fraction 1/3. This one is also divisible by 3. And we end up getting 15 over 33, which is then simplifiable again by 3, so we get 5/11. Then we're brought down to this one. 327, so that's 5, that's 12. It's also just kind of magic that they're all divisible by 3. So on the bottom we get 333, and then on the top, if we divide this by 3, 3 goes into 3 once. 3 doesn't go into 2, but 3 goes into 27 9 times. And we're done right there. So when the decimal repeats and every digit is part of that sequence, we get to put it over the same amount of 9s. When just some repeat, like 0.16 repeating, notice that it's just the 6 that's repeating. When we have a process like this, we're going to take the whole decimal, and then we're going to subtract the digits that are not being repeated. So I'm going to change this and I'm going to color code it. So I've got, so black, this number does not matter. We have the 1, we then have the 6, and the 6 is being repeated. So we take the 16, the whole number, and we subtract all of the non-repeating digits. That do not repeat. Sorry, my pen's not working too well. So we get 16 minus 1, that gives us 15. We're then going to add 9s for as many digits that repeat. For each repeated decimal. So there's 1, so we only have 1 9. But then we're going to add a 0 for each non-repeated digit. We then simplify if possible, and in this case it is. 3 goes into both of them, 5 goes into both of them, and then it turns out that 15 goes into both of them, and that simplifies all the way down to 1/6. So we're going to practice one more like this so you can kind of see the idea. I'm going to color code it again, so I'm going to have 0.23. Oops, I wanted to change the coloring. Apologize. 2, 3, 4, 5. So when we look at this right here, we have 2 non-repeated digits and 2 repeated digits. So we're going to first take the whole set of numbers, 2, 3, 4, 5, the whole thing, and we're going to subtract out the non-repeating digits. So 2,345 minus 23. Sometimes I find it easier just to line it up like this so we can see the visual. 5 minus 3 is 2. 4 minus 2 is also 2. We're left with 3 and the 2. Underneath, we're going to have 2 9s. And then 2 zeros. And that is the fraction that generates this decimal in its repeated fashion. I'll grab my calculator just to prove it. So I'm going to take 2,322. We divide it by 9,900. And we get that 23. And then the repeating 45 over and over and over again. The reason why this last 5 is not another 4 is the calculator runs out of memory, so it rounds when it runs out of space. So it's supposed to be a 4, but then that 5 that comes after it has rounded it back up to a 5. So forget about that last one right there, basically like that, and that sequence just repeats over and over and over again. Now we're going to convert, oops, we just did decimals into fractions. How do we take a fraction into a decimal? To take a fraction into a decimal, we have to do long division. So let's say I've got the fraction 3/8. 3/8, we've got the numerator up here, numerator, the denominator right here. The numerator goes inside the house. The denominator, oops, I don't know why I changed it to a 4. It's just an 8. Goes outside the house. And then we begin our longhand division. 8 does not go into 3. 0 times. We're going to add the decimal point that the 3 has right here. That way we can grab the 0 that's behind it. Once you've added the decimal point, you add it to the exact same location up above in the answer. So you've added it now, so you plug it in there. 8 goes into 30 3 whole times. 3 times 8 gives us 24. 30 minus 24 gives us 6. We bring down the next 0. 8 goes into 60. 7 whole times. That's 56. We subtract that and get 4. We then bring down the next 0. And 8 goes into 40 5 whole times. So the decimal for 3/8 is 0.375. If we had a different fraction that turns out to be a repeating decimal, let's say we've got 4 2/9. Since the 4 is the whole number, I get to put it right in front of my decimal point, and then I'm not going to use it again. So I'm going to take my numerator, put it inside the house, take my denominator, take it outside the house, and begin long division. 9 doesn't go into 2, so 9 is going to then go into 20 2 times. 2 times 19, or 2 times 9, I'm sorry, is 18, which gives us 2. I bring down another 0, and I see that 9 goes into 20 2 times. 2 times 9 is 18. I get 2. Bring down another 0. And we can see that this pattern is going to repeat over and over and over again. So once we have found our repeating decimal, I'm going to include it down here, and I'm going to put a line over all the digits that I know repeat, like this. I am also allowed to just put 1, 2. And if it was an improper fraction, let's say 15 thirds, no, that's too easy. 15 ninths. We just did a 9. Let's do something different. Let's do 15. I'm going to change it because all the ones I just thought up for 15 don't work the way I want it to. Let's do 17 sixths. 17 sixths. I could convert this into a mixed number right here, but I can also just put it into the house and let that convert it into my mixed decimal. 6 goes into 17 2 whole times for 12. 17 minus 12 gives me 5. All right, from here, I've added my decimal point, so I'm going to add my decimal point above. That 0 is brought down. 6 gets to go into 58 times. 8 times 6 is 48. Left over 2. Bring down the 0. 6 goes into 23 times for 18. Left over 2. Uh-oh, we're back to 20, which is another 3, which gives me another 18, which is going to give me another 2. There's the process right there. So we have 2.83, and then from there, the 3 will repeat forever and ever. That is converting fractions to decimals and decimals into fractions.